Hello, everyone. Thanks to the chairman and the organizing committee of the conference, and I'm very honored to be here to introduce my work, my master degrees. Today my topic is roots in the topsoil at the establishment and elongation stages contribute the yield response phosphorus select broad timber cultivars. I will introduce my work from 4 parts. As we know, the oil strip all run to the second in production and the oil strip and the plant area in China as well in the world. And it provides more than 42% of food oil for Chinese residents. And as a figure shown, in recent 30 years, the production and the plant area all account for 20% in China of oil strip. But the peat deficiency has become one restrict limiters for the production production increase of oil strip in China as well in the world. So in the world, the peat approximately about 70% of cultivated land suffers from peat deficiency, especially in the main plant area of China. The peat deficiencies have limited limiting factors for the production increase. So maximum and explore the root adaptability in the morphological and physiological traits are becoming more efficient. So on one hand, the peat efficient species through the root accumulation in the morphological trees to enhance the topsoil forgivings. And on the other hand, root secrete camzylate or phosphates to mobilize the fixed phosphorus or the organic phosphorus into the inorganic phosphorus and substitute by the plant. So the aim of study is one is to explore the adaptive strategies of Brassica roots response to soil phosphorus. The second is to explore the key growth stages of Brassica neighbors in peat replate and different conditions. The third is to explore the root trees that could be used to product the storage, acquisition, and seed yield of peat replate and peat deficient plants of Brassica neighbors. So based on the the root phenotype of the point and weak systems, we select 4 Brassica neighbor cultivars. So as for the results, one is the difference in steroid and root of 4 Brassica neighbors at high pH and low pH supplies. So we can we will show the steroid among the 4 Brassica neighbors. The cultivar 212 had the lowest steroid from overwintering to remaining stages at the post peat treatments. But for the cultivar 09 had the highest steroid among the 4 Brassica neighbors from boarding to remaining stages at the post peat supplies. As for the root steroid, we also found that among the 4 Brassica neighbors, the cultivar 212 had a lower root steroid from overwintering to remaining stages at the post peat treatments. And for the cultivar 149 had the higher steroid than the cultivars in overwintering, boarding, and remaining stages at the high P. And the cultivar 09 had the higher root steroid in boarding and silicon stages. So we also analyzed the correlation between the total peat acquisition and the steroid, and we also found that the total peat acquisition had a significant correlation with the steroid in each growth stages at both peat contribution conditions. And for the correlation between seed yield and steroid, we also found that seed yield significantly correlated with steroid in silicon and repeating stages at high P and low P in each growth stages. So the part is the coarse root in the topsoil at its intelligent elongation contribute seed yield to be graded and seed and steroid in response to phosphorus. So we analyze the correlation of steroid total acquisition and seed yield with the root morphology trees in the 0 to 30 centimeters. And it's about the total root length, root surface area, cross root length, and the fine root length. So we found that at high P in boarding and silicon stages. Total big acquisition and CDL and shoulder weight had a strong correlation with root surface area and course length at high P, and with the total root length, root surface area, and course length at low P. And the CDL had the significant correlation with the root surface area and course length in boarding stage at the birth speed treatments. So, as for the correlation, the shoulder weight, total big acquisition, and CDL with the root morphology trees in the 0 to 10 centimeter soil layers, we found that maybe have the identical results with the morphology trees in the 0 to 30 centimeters. So the specific result is that about the total big acquisition had a significant correlation with root surface area and the course length is topsoil at a high P, and with the total root length, course length, and root surface area in topsoil at in boarding stages at a low P. As for the shoulder weight, we found that he had the significant correlation with the root surface area in the topsoil in the silicon stages, and with the total root length, root surface area, and course length in boarding and silicon stages at the low P. So, but for the CDL has the identical results is it says he had a significant correlation with the root surface area and course length in the topsoil in boarding stage at both speed treatments. So, but for the root morphologies in the 10 to 20 centimeters, we only found have the significant correlation with at high P. The results as in the root morphologies in the 20 to 30 centimeters, we also only found have the correlation in the high P. So as for the root physiological trees, just such as the acid phosphate activity, rhizosphere pH, and the organic acid content, we no found the correlation in interior growth stages at the birth speed treated supplies. So we use 8 root trees, including 4 root morphologies and 4 physiological trees to conduct the principal component analysis. We found that in boarding stage, the root morphology trees as the PC1 could explain the 58 and 41 variation, present variation among 8 root trees in boarding stage at the high P and at the low P respectively. So we further to get to analysis the course roots about this the surface area of course roots from seeding to repeating stages. We found that you can see this from seeding to boarding stages at high P and low P. The root surface of course length significantly increase, and along with the root surface area increase of the course roots, the shoulder weight in the middle at high P and low P, and the total big acquisition had with expansional growth at high P and low P. So the 3 is the cultivar 09. For this cultivar, we found that maybe have the higher root morphology scores, and the result is we use 5 root morphology trees and 5 root physiology trees to in the root morphology trees in the topsoil, such as the specific root length, total root length, root surface area, course length, and fine root length. We found that in the boarding and settling stages for the cultivar 09, it had higher significant root morphological scores than other cultivars. So we further to analyze the genetic difference in the root morphological trees, and found that as for the root surface area and the course length in the topsoil, we found that the cultivar 09 all had the highest and significantly higher root surface area and course length. So as for the P acquisition efficiency, we also found that the cultivar 09 had the highest PAE than other cultivars at both P conditions. So as for the P utilization efficiency, so we show the in interior growth stages, we found that the maximum PUTE showed in the sequence stages at the birth peak supplies. But for the Cultivars Ronan, he had the highest PUTE in sequence stages at high P. And in the low P, there has no significant difference. So for the CD yield and harvest index, we found that the Cultivars Ronan had the highest CD yield at the other cultivars at high P and low P supplies. But as for the harvest index, we also found that Cultivars Ronan had the higher harvest index at high P, but at low P, there have no significant difference. So let's make a conclusion. The one is the genetic difference was observed in root adaptability of morphological and physiological traits in P replant deficient conditions in field in select browning carriers. The two is the root morphological traits may be a better protector of total P acquisition, should draw it, and CD yield than root morphological traits in Brassica nippers in the field. And for Brassica nippers, we found that maybe the coarse root in the topsoil, maybe the established and elongation for the coarse root in the soil maybe improve the penetration ability into the soil in the heterogeneous soils to improve the root to as the scaffold for the root proliferation and widen the root surface area to conduct more phosphorus. And the more coarse root will improve the total P acquisition, improve and should biomass accumulation. So will have a seed yield and in the end have the higher harvest index. So it's based on our now results to give this model maybe to verify through many next work. So this about so we found that in the high P and low P have the different morphological root trees have the function. So we found that at high P the highest coarse length and root surface area in the topsoil. As for the cultivar Throna, had the highest dry weight, total P acquisition, and CD yield. For the cultivar 212, the lowest total root length, coarse length, and root surface area will have the lowest shoot dry weight, total P acquisition, and CD yield. So in the end, I will thanks my supervisor, Professor Leish, and Dr. Kermojin for their careful guidance, and each teacher and students in my group, and thanks to the foundation of supported by the National Key Research and Development of China and the National Natural Science Foundation of China. So thanks everyone. Thanks for your attention.